Hi, and welcome back. In this next lesson, we're going to be talking about vSphere with Tanzu Storage. And we're going to explain to you how our solution is being implemented to be able to provide persistent storage for your containerized workloads. So in order to do that, you need to understand the architecture inside how Kubernetes has developed what's considered a plugin style architecture that allows different vendors to plug their solution into the Kubernetes ecosystem or platform. VMware is doing that by using a thing called the Cloud Native Storage, or the CNS, for vSphere that allows us to plug into our vSphere storage into the Kubernetes architecture. What we're doing is we're going to take virtual machine storage policies. If you're familiar with vSAN, you've used storage policies. And we're going to expose them or implement them as a Kubernetes storage class. This is going to give us the mechanism that we're going to be using to store our Kubernetes persistent volumes and its counterpart, the persistent volume claims in Kubernetes. And we're going to give you an easier tool to manage that and to give you visibility to monitor these persistent volume claims. And that's going to be your vSphere client. So what Kubernetes has done for storage is they've created a thing called the Container Storage Interface. That's the plugin architecture that a third-party vendor would need to program to, that series of APIs, to be able to implement their storage platform into Kubernetes. VMware has done that. We've implemented our CNS to be able to integrate with the CSI to be able to expose vSphere data stores and storage policies into Kubernetes. Any vendor, any third-party provider can enable their storage platform and by simply taking a look at the plugin architecture and the APIs that they've got to conform to. So what the CSI does is it provides a common standard for exposing the external storage systems into Kubernetes. So what we're doing when we use the CNS is, first of all, the CNS is a service or a server that is running on your virtual center server. And we're going to give you an architectural picture of the actual flow of everything that goes on, what components are talking to what, but the CNS resides on your virtual center server. And when he sees a request, the service sees a request to say that we want to provision a persistent volume or a persistent volume claim, it starts the appropriate allocations and communication to the various components that are actually going to do that specific provisioning. So if I say here, you've got your pod, and inside your pod is a container that needs a persistent volume. So what we need is we need a disk here that is going to ultimately get mapped into your pod. Well, what do we use normally in vSphere to represent a disk? Well, we represent disk as two files, the VMDK and the -flat.vmdk. That still exists for your pods when you're using persistent volumes. We've got a term that we use for that, and that is what we refer to as a first-class disk, an FCD. That's what we're using to support our container volumes. Now, this is going to implement or integrate with our existing storage policy-based management system, SPBM, that's going to steer us to which data store we're supposed to be putting this disk on. So down here on my ESX host, down here, he might have access to a series of different data stores down here. The question is, which data store does he put it on? And using our SPVM that we're defining on our namespace. So remember in the previous module, when you created your namespace, there was that second to the last in the upper right-hand corner where we were doing our storage. It's this storage policy that we're choosing that's going to determine via the CNS system and the SPVM which one of these data stores will the first class disk be stored on. We've got our vSphere system sitting down here. So here's our vSphere system. Above us, we're running Kubernetes. Kubernetes doesn't use SPVM. SPVM is a vSphere construct. Kubernetes uses something called storage classes. So what's happening when we implement the CNS and we start targeting an SPVM specific policy, what we're doing is we're basically translating or correlating a specific SPVM policy down here, and we're going to basically define it up in Kubernetes as a storage class. Now, you could see that, let's say I have namespace A and namespace B, and again, I can create several namespaces. Each namespace, I get to choose which SPVM or plural M's that I want to use inside that namespace. This namespace, we're using one storage-based policy management. Here, we're actually using two of them. I could reuse an SPVM for multiple namespaces. This one has two, so it also has the silver one. This SPVM over here is never even referenced in the namespaces that we're showing you here. So as you can see here, our VM storage policies get translated into Kubernetes storage classes. The developers that are our customers, the ones using our namespace, they're going to be able to gain access to any of the assigned storage policies, which are going to appear to them as a storage class. However, they're not going to be the ones that are managing the storage classes. That is still being reserved for us. We're controlling the storage on our vSphere system. This is the namespace that I was telling you about. And you could see over here in the upper right-hand corner, when I edit my storage, I could put in which storage policy I want this namespace to use. And in this particular example, I've actually defined two storage policies that I want to use. What are my developers going to see? They're going to be over here in kubectl, their common, command line interface that they're used to using. And they're going to do a describe on their namespace. And you could see down here where they're seeing the two storage policies that we've assigned over here in the HTML client being translated into a Kubernetes storage class. That's the underlying architecture. Now let's talk about consuming it. I put in the foundation that I could start using these storage classes. They're going to be used by my persistent volumes. So I'm going to pause for a second here and back up for a minute. Depending on what your Kubernetes experience is, you might not fully understand this. Containers are, if you don't do anything special to a container, its data or its disk is going to live for as long as the pod exists. So when I deploy my pod, I get new disks attached to the pod. If I delete my pod, the disks that were associated to my pod go away. We're not used to that. We're used to, okay, if an application crashes, a VM dies, I restart it, its disk is still there. Whatever data's been written to it is going to be represented, and it is going to be persisting until I actually intentionally delete the VM, including deleting, not just removing from inventory, but deleting from disk. In the Kubernetes world, pods, if they get destroyed for some reason, maybe it's a failure, maybe the Kubernetes scheduler is, we're draining a worker node, and I need to move the pod from one worker node to another worker node. A variety of reasons in Kubernetes would cause the pod to be temporarily removed and recreated somewhere else. That's going to result in all your data that was associated to your pod being lost. The majority of Kubernetes containers, when you're looking at a multi-tiered style application, if I had my monolithic application over here, if you looked inside your monolithic application, there's a series of clear, I'm going to call them functions inside your application. Maybe I've got the web front end, maybe I've got some various app pieces inside of it. Maybe back here I've got some API reference. Maybe back here I have my database component sitting back there. When that application gets refactored into cloud native, and we're going to basically break things apart, turn a lot of that into microservices, we end up with a series of self-contained, pods or containers. And if I looked at this percentage of them, these up here could really be written in such a way so they're stateless. And that's the normal style. You're going to find that a big percentage, I'll say 80% of the containers you're running are stateless. Now, we do know, ultimately, for me to recreate this application, this database component or pod has to persist the transaction. So how do we make that so that if something happens to that container or pod, if it gets moved, rescheduled, whatever is happening, I need its data to persist. You've got to go through special steps to do that. So we're going to take a break here for a second. And I want to close with making sure you understand that when you're looking at running your containers, again, there's going to be some ratio. Your mileage is going to vary, but probably I'll say like 80% of them are going to be stateless containers. And then some smaller percentage over here need to be stateful. So if I'm doing something in the stateful regard, it has to be defined with special components in Kubernetes to make it stateful. And when we come back from our break, that's where we're going to talk about how do I define persistent volumes.